Hare Krishna everyone. So in today's lecture I am going to start with your atomic physics. That is our lecture number 4 of atomic physics. So in today's lecture I am going to start with your Muonic atom, a very important for your entrance exam prospectus or your uh, uh, BSc books. Okay, let's start with your Muonic atom. Okay, generally we have to say this muonic atom as your muonic hydrogen atom. We are going to derive its expressions and also the velocity and radius of the orbit also. Okay, let's talk about this in details. Yes, if we replace if we replace if we replace if we replace electron of hydrogen atom electron of hydrogen atom by a muon. I, I will talk about what is a muon and what are its properties in this section also. Yes, if we replace electron of hydrogen atom by a muon generally is a lepton, okay, which is come under your fermion group, okay, and having half integral spin. Atom by a muon, we can say it as mu meson. we find we find a muonic muonic that is mesonic, or you can say mu magic atom of short lifetime. Okay, so let's talk about it in detail. What are the properties of muons? Let me talk about that. What is properties of muons? As I have told you, muon, that is meson is a lepton family member is a lepton family member is a lepton family member. Muon has mass, that is mass of muon is 207 times that is mass of electron, and it is half integral spin. It is half integral spin. Half integral spin. Half integral spin. This is a fermion. If it has half integral spin, then we can say it is belongs to the fermion group. This is a fermion. This is a fermion. Okay. Okay. Sorry for the disturbance. Let's resume with our class. Yes. Let me erase this one for you. Yes. So this is a fermion. Okay, and its lifetime is its lifetime is, that is 2.2 microsecond. And if I will have to write its decay reaction of muon, it will be, let me change the color of the pen, that is mu muon will decay into to give electron and a anti-electron neutrino and a muon neutrino. This is your electron, okay, and this is your anti-electron neutrino, and the last one is muon neutrino. Okay. So mass of nucleus is your mass of proton, that is 1836 times of mass of electron. So mass of muon, we have mass of muon is equal to 207 times of mass of electron. So reduced mass, so for reduced mass we have mu is equal to small m capital M divided by small m plus capital M. So it will become small m, in place of small m you have to substitute, that is mass of muon, that is 207 times of mass of electron into 1836 times of mass of electron divided by 207 me plus 1836 me. Okay, is it clear to you? I have just substituted these values. Okay, if you calculate this, you can get mu is equal to your 1836 me. Okay, if you substitute you can get this value. Okay, so let us find out the radius. The radius for muonic atom, the radius of nth orbit in a muonic atom. Muonic atom. Okay, let us find out. Let me change the color of the pen. Yes, so we have radius formula Rn, that is muonic, is equal to h square epsilon naught upon pi mu e square. Okay, in place of m I have substituted mu into your n square. That implies 1 by 186. Sorry, I have written this 1836. It will become 186 only. Okay, it's my mistake. 186 only me. Yes. So in place of mu I have substituted this. So it will become h square divided by pi m mass of electron into e square n square. Okay, so further substituting I will get Rn muon will be 0.53 Armstrong upon 186 into n square, isn't it? Yes. Further it will become Rn muonic will be equal to your 0.285 picometer into your n square. Okay, this one is the final expression for radius of nth orbit in muonic atom. Okay, let's find out the velocity of muon, in nth orbit of muonic atom. Let us find out the velocity. We have found the radius, let us find the velocity. Yes, and after velocity we can get the value of energy also. Yes, so Vn muonic will be equal to your Vn hydrogen. Okay, so it will become Vn muonic will be equal to 2.18 into 10 to the power 6 upon n meter per second. Okay, make it a bracket. Yes, so let's find out the energy expression. The energy of muon in nth orbit of muonic atom. Okay, let us find out that. So energy of muonic atom will be equal to your mu e4. I have substituted in place of m, that is mu, your reduced mass, divided by 8 h square epsilon naught square into 1 by n square. Okay, where m is substituted by your mu. So it will become 186 into me e4 upon 8 h square epsilon naught square into 1 by n square. In this step, what I did, I have substituted mu as your 186 times mass of electron. Okay, so it will become En muonic will be equal to 186 into En of your hydrogen atom, that is equal to 186. We have energy of hydrogen atom, that is 13.6 electron volt divided by n square electron volt. I have already written there. So on calculation you can get the final expression for energy, that is minus 2529.6 upon Na square electron volt. Make it a box. Okay, yes. Let us find out for n is equal to n is equal to 1, 2 and 3 and up to infinity. We can calculate this energy value. Let me found some for one, that is Bohr orbit. So energy will become how much? En will be become minus 2529.6 electron volt. That is for n is equal to 1 square it will become 1. So E1 is minus 2529.6 electron volt. For n is equal to 2, you have E2 is equal to minus 632.4 electron volt. You can calculate. I have already calculated the values. You can also calculate. E3 will be become your minus 281.06 electron volt. Often calculating, you can get for n is equal to infinity, you can get the value that is E infinity will be equal to 0. That is ionized state. Okay. Let me draw the energy diagram for you. If I will draw the energy diagram, what I will get, let me change the color of the pen. Yes, this one is the ground state for n is equal to 1, for n is equal to 2, for n is equal to 3. If I will have to show n is equal to infinity, then I will have to show like this, n is equal to infinity, that is your ionized state. You can, this one is E1, E2, E3. This is E infinite, that is your ionized state, and this is your fast excited state. This one is your second excited state, and this one is your ground state. Okay, this is the energy level diagram for your muonic atom. Okay, so what is the binding energy? Of muonic atom? Binding energy of muonic atom in ground state. That is equal to infinite minus E1. That is equal to E infinite is 0 minus 2529.6 electron volt, isn't it? Minus become plus 2529.6 electron volt. This is your binding energy for ground state of muonic atom. Let us find out the Rydberg constant for muonic atom. Rydberg constant. Okay. R muonic, that is your mu E4 upon 8 HA cube epsilon naught square C, that is equal to 186 into mass of electron E4 upon 8 HA cube epsilon naught square C. If you remember, this one is the expression for R infinite. That is your Rydberg constant for hydrogen like atom. 186 into R infinite, isn't it? Yes. This one is your R muonic, isn't it? Yes. Make it a box. Yes. If I will have to find out the wavelength of spectral line for transition, I am doing an example for you. Transition N2 to N1, what it will be? How can I find out this? Let's see. That is 1 by lambda is equal to R muonic. I am doing it for muonic atom only. Yes. 1 by N1 square minus 1 by N2 square bracket. So it will become 1 by lambda R muonic is equal to 186 times your R infinite into 1 by N1 square minus 1 by N2 square. This one is your expression for wavelength, isn't it? Yes. Okay, so for this class I have ending this lecture with your muonic atom. Okay, if you want to find the PDFs of this lecture, you can access it through my Telegram channel. I will share my Telegram channel link in the description box, so you can find it there. So thank you for everyone for your patience. Thank you everyone.